So say hypothetically 3D3 you've done, but you're not really strong at it yet. You aren't able to read the transformations directly. Then we work backwards. So here we go. We're going to work backwards. We're going to bring it to the original function. So this is something, it's a fraction with a square in the denominator. So we know it's a truncus function. Truncus function will be y equals 1 on x squared. So your goal is to undo everything that you see here and bring it back up here. Okay, so if there's a 1 up there, I need a 1 here. There is no vertical translation. There shouldn't be a vertical translation here. And there's nothing to do with the x's here. That's what I don't want. Okay, so I'm going to try and move everything back. So how do you do that? Same thing as what I just showed you before. So before was confusing. Hopefully it's the second time for you to look at it. So let's put the dashes in. This is your new y, new x. Remember, your original function's up here. You're replacing original x with x dash minus 3, because that's what you're squaring. So right now you're squaring the x, and that's what you're squaring. So I like to start off with the x's. The x's are the easiest one to find first. So in my transformation, I can already see original x is equal to x dash minus 3. Your goal is to find what the transformation is for x dash. So let's solve for x dash here. Adding 3 on both sides, x dash now equals to x plus 3. What does that mean? That means the transformation just for the x's only, and that's the easiest one to read first, is that I know it's original x plus 3 will give me new x. So if I read that, that means to the right by 3. Okay? And that's what I mean. After you do it a while, you know just by looking at the equation, you can figure it out. It's to the right by 3. Okay? Next one. I need a y transformation now. So I need, what is y dash equal to? So same thing. We go back and we have a look. This is your original y. I need a 1 there. It's not a 1. So that 2 does not belong here. That belongs with the y transformation. So I need to bring it over. That plus 4 is not existent. So that must be with my y transformation. So you're going to move everything across. So here we go. Let's go backwards. Starting from here, I'm going to undo that plus 4. So minus 4, minus 4. This gives me now y dash minus 4 is equal to 2 over x dash minus 3 squared. These cancel out. I'm almost similar. See, it's almost similar to the original function. I don't have anything here, and I don't have anything there. That's something squared, that's something squared. That's great. That's to do with the x's. And then you get rid of that 2. So that's a 1, that's a 2. Again, to get rid of that 2, I can now go back and say, well, let's divide this side by 2. Divide this side by 2. 2 divided by 2 cancels out to be 1. And that's why in the next line, I have y dash minus 4 over 2 is equivalent to 1 over x dash minus 3 squared. Can you see how I'm moving backwards? So now I can clearly see that original x has been replaced here. Original x equals x dash minus 3. And the original y is equal to this entire left-hand side. So if I highlight it for you, I'm saying this equals that. And then I'm saying original x equals this. Because you're only interested in the transformation. You're not interested in the function. The square stays there. The 1 on something, that's the function. This one I'm interested in. So we worked out the x transformation already. Now to do the y, let's do it again. Same thing. Original y is equal to this one, which is y dash minus 4 on 2. Your goal was to find y dash. So I need to rearrange this equation to get y dash. So times 2 to both sides, add 4 on both sides, and you can see this is how I get the next line. This becomes 2y equals y dash minus 4. Y dash will then equal to 2y plus 4. So if I write it all back in here, y dash now equals 2y plus 4. And that's what I was saying before. See, over time, you start to see a pattern. See, when it's times 2 here, that's dilation of factor 2 from the x-axis. There's the 2. When it says plus 4, can you see that plus 4 means shift up by 4? It's here. So over time, when you look at the equations, you're able to start to see, oh, every time there's a plus, minus, the y transformation is the same. But what's the pattern is that anything to do with the x's, if it was x minus 3, it ends up being x plus 3. If it was 2x, it ends up being half x. And that's the pattern you start to recognize. And eventually you don't have to do what I just did. You look at an equation. Does that make sense? Okay, so 3f, oh, so is this 3f? Yeah, this is 3f. Your ability to sketch quickly depends on how fast you can see the transformation. So when I look at this equation, what I'm seeing is this. In my mind, I know a truncus function looks like this. That's a 1 on x squared function. Two asymptotes, vertical and horizontal. Now, based on what I know, it goes to the right, right by 3. So it moves to the right by 3. So here we go. The vertical asymptote shifts across to the right. X equals 3. The graph goes up by 4. So that means the horizontal asymptote now shifts up by 4. Okay, can you see what I'm doing? I'm taking, if I shifted the graph up, then that horizontal moves up. If I shift it to the right, then that vertical asymptote goes to the right. I now have my axes. It's a truncus function. What else do I know? There's no reflections. It's dilation, but no one knows it's a dilation when you sketch it like this. So you can literally find out the y-intercept, and then you've got your graph. Okay, so exercise 3F relies on your ability to look at an equation or solve it very quickly and then do this, what I'm showing you. Okay, so if I go to Desmos, let's go to Desmos to consolidate our understanding. So this is what I was showing my year 11s to be able to read transformations for quadratics. You guys are now at a point where you're going beyond just quadratics. This is 1 on x squared. So that's what a truncus function looks like. I'll put it in as some variables for you to see. Can you see when I put in the brackets, anything you write in x here will affect the horizontal transformation. So if I put a plus b, okay, and then on the outside, I put a plus k, what you can see is that when b is positive, it moves to the left. When k, so that's your vertical translation, if I change that, it goes up and it goes down. So in our case, we wanted k to be 4, because we said up by 4. We wanted b to be x minus plus 3. So x plus 3. And wait, was it plus 3 or was it minus 3? Minus 3. Oh, there we go. That's why it looked a bit different. Minus 3. And you can see the asymptotes. Asymptote is at x equals to 3. And you've got your other asymptote at y equals 4. You see that the graph never touches y equals 4 because you shifted up by 4. And then y has the other vertical asymptote move to the right because you shifted the graph to the right. So if I did a comparison now, let's just type the original one, y equals 1 on x squared. You can see where it's gone. It's gone from here to the right, up by 4. Okay? What's the difference in our one? We had a dilation of factor 2. So I was meant to put a 2 here. If I put a 2 there, you can see just a slight difference. This is a factor 2 from the x-axis, so everything gets stretched vertically. And that's what's happening here. Everything gets pulled up. That's why it looks a bit wider. Cool? That's exercise 3F. I'm going to probably pause here for today and then continue with G, well, bit of F again, G and H, so that you see the idea. But really, you can't do F well without knowing D and E. So D and E allows you to be able to do what I was just being able to do, where I can look at an equation and tell you what the result is. So that means you want to be able to do this. If you go back to this exercise, doesn't matter which function I give you, you need to be able to look at this and say, left by 2, dilation of factor 5 from the x-axis. Down by 2, reflection in the x-axis, dilation of factor 5 from the x-axis, here's left by 2. Okay, so if you're able to read these, you can sketch them all on axis and y-intercepts like you normally would. That's the transformation skills. And you want to do a variety so you get familiar with how to do it. If you can't read it yet, use skill from 3D and 3E. It's very, the core. 3D and 3E is very core. That's how you learn how to read what I just did. Okay, that's the ability. Cool, I'm going to stop the video because I don't want to overwhelm you, especially if 3D and 3E is something you haven't mastered yet. I'll come around and just make sure that you're understanding what I'm saying. Cool? All right, I'll stop here.